All right, here we're looking for, again, we're looking for work. Well, we're looking for power. And how are we going to do power? Remember, there's a couple ways we could do power. We could say power is equal to work over time, and we could say power is equal to force times velocity. We don't have a force in this case, right? In the motorcycle problem, we know what the force was to overcome resistance because it was moving at a constant speed. Here, how are we going to do work? Where are we going to get work?
You, isn't that the average speed? So couldn't you do 0 minus 27 and
No,
then have velocity?
that's the final speed.
Yeah, but then isn't that average speed? So you'd have delta V.
How is average speed equal to final speed?
No, that's I no because
So
then if you 0.
we could do this by dynamics. This could be done with F equals ma and with kinematics. Okay, but let's run through the problem and then I'll answer questions in a second. Okay. All right. So how are we going to find out? It looks to me like this is the relationship we're going to use. But how are we going to find out what work is? What's the other way we do work? Work is force times distance, but we don't have that. What's our other thing for work? Well, work is equal to change in kinetic energy. All right, since the cheetah starts from rest, that means the work done on the cheetah, by the cheetah, all right, is just going to be whatever its kinetic energy is.
That's what I meant, like
Okay. All right, so then we got power is going to be equal to its final kinetic energy divided by the amount of time. But what does that mean? Power is equal to 1/2 mass of the cheetah times its final velocity divided by t, or more appropriately, mv squared over 2t. All right, we've got all those numbers. This is just a simple matter of plugging stuff in. Power is going to be equal to the mass of the cheetah, which is 110 kilograms, times its velocity, 40 meters per second. Isn't it 40? I'm sorry, yep, 27. 27 squared, all right, divided by 2, and how much time? That's where I got the 4. All right, 2 times 4.0 seconds. So we got dimensionally kilogram meter squared per second cubed. That's watts, all right. All right, so when we plug all that in, all right, so what do we get? Calculator brigade. This gives us 1.0 times 10 to the fourth. Again, kilogram meter squared per second cubed is watts. Watts. That is correct.